don't really need to know certain sections. Right, 5.2, moving on to 5.3. Predicting direct redox reactions. We kind of already know this, right? Mention this idea that when we're looking at the electrochemical series about making predictions, we identify the chemical species that are present, right? And then I determine which is the stronger oxidizing agent and which is the stronger reducing agent, right? So we slide for spontaneous. If we have to go up the hill, it's non-spontaneous. So, however you remember this, backwards C, there's an S in there, so an S for spontaneous, however you want to remember it. Okay. So if we consider the following that appear in the electrochemical series, predict the effect of the following: bromine and magnesium 2+. Get your best friends out. Who's forgotten their best friend? Again. Who's your best friend? Or she? Right? Get your best friend out. Or find an electrochemical series online and let's make a prediction. Where's bromine? Where is that? Bromine's here. Right, cool. Where's magnesium 2+? Well, it's already shown here. Right, it's there. It's on the same side. Spontaneous or not? Yay or nay? Who says yay? No. Who says no? Who's indifferent? Who abstains? Right, I've got one no. No is correct, right? Same side, non-spontaneous. Cool. Which of those two is the stronger oxidizing agent? Bromine is correct, right? Higher on the electrochemical series on the left-hand side. Magnesium 2+ and nickel. Yay or nay? Who says yay? Yay. One says yay. Who says nay? You agree with Anton. You didn't say yay, though. Right, non-spontaneous. Slide up. Right? Nickel is a weaker reducing agent than magnesium. Non-spontaneous. Nickel 2+ and magnesium. Yay or nay? Yay. Yay is correct, right? So, slide spontaneous. Magnesium, stronger oxidizing agent than nickel. It will preferentially oxidize. The nickel ion will preferentially reduce because nickel ion is stronger reducing agent than magnesium. Oxidizing. On the index page, did I put it on the Canvas page yet? If it's not there, then it's on the index page that you've had access to at the end of last year. No, I can send it to you again. Cool, moving on. All right, cells and batteries. We're going to talk about batteries today. So far, we've only been looking at primary cells. What does the word primary mean?
Disposable and not rechargeable.
Oh, yeah.
Nice.
Right. Where else have you seen the word primary? What does it mean? It means the first. Right. So primary means one. So there's only one use. We can't recharge it. Make sense? Primary means one. It's disposable. It's not rechargeable. One use only. Discharges, that's it. Battery flat or dead, I would say. Secondary cells, what does second mean? Two. So it means it's rechargeable. Can go both ways. Two ways. Now, the key feature about secondary cells is this, and I want you to write this down. Secondary cells are rechargeable because the products of the discharge reaction must remain in contact with the electrodes. What I mean by that is they don't migrate away. They're not like you when you leave home. You always come back. Parents are always delighted when you come back. I'm 38. My parents are still trying to get me back to Swan Hill. And I keep saying it took me 13 years to get out of Swan Hill. And that was as fast as I could get out of Swan Hill. Didn't work. Keep going back. Parents are still there. Have an obligation. Not really. I really do like my parents. So, the feature of secondary cells is that the products of the discharge, right? So I'm thinking galvanic discharge. Recharge, I'm thinking electrolytic. We'll get to that later. Primary cell, one use only. Makes sense. So we talked about polarity, or we talked about the charge of the terminal. I don't know what number. What number are we up to? 28. Okay. I'll just skip through these examples. Secondary cell. Products must remain in contact with the electrodes. Accomplished by, so the recharge bit comes through an external power source. So discharge, spontaneous, and exothermic. Recharging, therefore, is? And? Non-spontaneous. So we need to give the battery energy. If I have a 12-volt battery, say a car, what voltage do I need to recharge that battery if it's flat? No. Well, you are correct, technically. More than 12 is the correct answer, okay? We can't give it 12. It's a 12-volt battery. If I give it 12, where's the electrons going? What does voltage mean? What's volts? Potential difference, yeah. What does it mean? What's the other thing we call it? Yeah, sort of about energy. What's the other word? EMF. Motive. Motive means movement. Force. We're forcing the electrons in the other way. So if it's 12 volts when it's discharging, I give it 12 volts to try and recharge it. It's like I'm pushing against myself. Yeah, I'm not going anywhere if it's the same. So it must be greater than in order to recharge. It can be 12.01 volts. It's going to take a long time to recharge, but that's all it needs. Lithium-ion batteries. Right? Recharging. During discharge, oxidation occurs at the anode, right? And Euler-Rigel cap. That still remains. Oxidation always occurs at the anode, no exceptions. The beautiful thing about redox, there's no exceptions to an Euler-Rigel cap. The difference is that oxidation still occurs at the anode, but the oxidation occurs at the positive terminal when recharging. It makes sense, right? You've got the discharge reaction, the discharge in your half cell. It's simply the reverse reaction. So you've gone from oxidation to now reduction, yeah? And it's at the location of the negative terminal. Does that make sense? Yeah? 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 Okay. How batteries work. You want to watch the videos? Yes. Okay. I've got this rechargeable galvanic cell, right? Luigi Galvani, that's where we get the name from. Also called a voltaic cell from Volta. Based on nickel and cadmium, NiCd cell. Commercially available for a number of years, used to power small appliances such as mobile phones. Well, they're more lithium-ion batteries now. But simplified diagram of nickel-cadmium cell is given below, or to the right in this case. Paste of CdOH2 plus KOH, pour a separator filled with KOH, paste of nickel hydroxide plus KOH, nickel OH solid. Cadmium and then steel. Where's my mouse? The overall cell reaction for the cell when discharging, right? Discharge, think galvanic. Identify the positive and negative electrodes by writing plus or minus in the circles provided in the diagram. Pause it there and we can talk. And the last question was? Give the equation for the half reaction that takes place at the electrode connected to the negative terminal of the power supply when recharging. So this is still the negative terminal. When recharging will be simply the opposite of what you've got, yeah? All right. Here we go. Let's break it down. So 6% of students got this all correct, right? The average mark, 4-mark question, average mark, 1.6 marks. Just to show you that students do it terribly. 22%, so almost a quarter of students got nothing. 33% got 1, probably this one, got the 1 mark by getting it right. 50-50 chance and still only 33% got it right. 24% got 2, 15% got 3 marks. Let's look through them. Only 6% got 4 marks. It is disappointing. Okay. Products of the discharge reaction. So there's our first mark. So negative at the top, positive at the bottom. Yeah. Part 2. Products of the discharge reaction stay in contact with the electrodes. Fairly straightforward. That is the fundamental, right, reason. Almost think of that word for word in case you see it on an exam. Right? Yep. Now, I'll talk about that in a moment. Part 3, cadmium plus hydroxide gives me cadmium hydroxide solid. Now, I don't know if it was accepted if you just went CD to CD2+. Right, because it's alkaline conditions. Alkaline conditions, it's the hydroxide ion that acts as the oxidizing agent. Really, it's a transfer of hydroxide, and then we balance with the appropriate number of electrons. A couple of you, right, tried cohes, which makes sense from all the ones we've looked at, but it's alkaline. Cohes only works in acidic conditions. There's a transfer of hydroxide, not hydrogen ions. So here was the examiner's comments. Parts 3 and 4 proved difficult for most students. Question 3, it was expected the product at the negative electrode, that is cadmium hydroxide, would be a part of the half equation, solid. Yeah? Many students achieve this by incorrectly using water as a reactant and H plus as a product. So here's my comments. Think application, don't think cohes. So if you see the word alkaline, or if you see that there's KOH or OH involved, you know you can't use cohes. Now, it's not an expectation to be able to balance with OH minus. But if you're given this application, you should be able to derive these from the overall. Or you'll be given these and determine the overall. Okay? There we go. So that finishes us up for today. So we can look at fuel cells in our next lesson.